Alright friends, so I'm going to be explaining something real quick about gravity. Now assuming this is the Earth, okay, and this smaller planet, let's not say planet, this smaller body is the moon, and this is the Earth. Now assuming a body of mass m was on the Earth's surface, and that same body of mass m was also on the moon's surface. Now, this body on the Earth's surface happens to jump upward. Okay, let's say it gets to this height h, then this is the body. Okay, and then this same body on of the same mass on the moon happens to jump upward. Okay, let's say it gets here h, and then this is the body. Now, we don't expect the scenario on the Earth to be same as that on the moon. Why? Reason is that gravity on the Earth is different from gravity on the moon. Okay, and for comparative cases, gravity on the Earth is approximately 6 times gravity on the moon. So this is our reference point. That is the force that is tending to pull this body back towards the center of the Earth. Let's say this is the center of the Earth, is 6 times greater than that, tending to pull this body back towards the center of the moon. So what do you notice? Because there's a greater downward pull, this body can go for lesser heights compared to the height that this body, same body, can cover on the moon. So let's say in this case, this body appears to cover a height of HE, okay, and on the moon it appears to cover a height of HM, that is height on the moon, height covered on the Earth. We will notice that height covered on the moon is greater than height covered on the Earth. Okay, that is what will happen. Now, what will actually happen, because gravity, if we are comparing gravity is 6 times that of the Earth. That is, there is stronger force here acting to pull this body downward than on this moon. Because it's 6 times stronger here, this body can cover a height 6 times than it will do on the Earth. So we can say height covered on the moon is actually 6 times height covered on the Earth. So these are the derivation you should know. Even without being to the moon, there are some stuff we should know that, okay, if gravity on the moon is 6 times lesser than on the Earth, that is to say, gravity on the Earth is 6 times greater than on the moon, a body on the Earth can cover 1/6 of the height the body, that same body, can cover on the moon. Okay, because of the what? Force of gravity difference. And so basically this is what we experience, what astronauts and other space explorers experience when they land on the moon. They kind of notice that they cover greater heights, okay, for the same energy expended in jumping than the same height they reference they can cover on the Earth. And you know one thing about this stuff, because the downward force pulling the body towards the center of the moon, which we call the force of gravity on the moon, is 1/6 that of the Earth, that it is very much less, the body will notice, we have this cognitive feeling that is spending more time in the air. So the person will be thinking is actually floating. I don't know if you get me. You'll be thinking it's floating, because let's say normally the time it will take for this body to get down is just 1 second. That means as it's going up, it's coming down immediately. On the move, the body can spend a time reference of like 6 seconds. So that 5 seconds more will appear to the person's cognition like I am floating. I am floating. Okay? So basically that's what astronauts think when they land on the moon. They kind of think there is no gravity, and that they are relatively just what? Floating in the air. There is gravity, but it's just 1/6 that of the Earth. That is very much less, such that you can cover a height 6 times than you would on the Earth. And you can normally, if you are spending 1 second in the air on the Earth, you can actually spend 6 seconds in the air on the moon. I hope this what I call it, this explanation is kind of clear to us. Thanks for watching.